Hi, my name is Jose Rolazon, and this is my Lab 1 for Physics 2. So a little bit of an introduction. The purpose of this lab is to observe the interactions of two charged pieces of tape and also to determine the amount of excess charge on the pieces of tape. Some model and physics principles we'll be using is Newton's second law, which we're very familiar with from Physics 1, Coulomb's law, uh, which is right there, the force of gravity, which we should also be familiar with from Physics 1, and then the constants K, which is 9 times 10 to the 9th, gravity, which we should be familiar with, and the charge of one electron, which is 1.6 times 10 to the negative 19. A small preview of our results, we saw that there was an interaction between the pieces of tape, and that the charge on the tape was the number down there, and that the amount of excess charge on the pieces was that number down there. All right, so how do we get those numbers? So we determined that the system in this experiment, over here, is tape B, and the surrounding was tape A and everything else. Through measurements that we did during the lab, we saw that we got all these measurements, and we were given that the atom length is 1 times 10 to the negative 10th, but since we also need the area to find the actual number of atoms, we multiplied this again by itself to get this number, and then we divided it by the tape area, which is this number right here, to get this number right here. And then we also saw that the distance between the tapes while it was floating was this number right here. Okay, now with all those numbers, we calculate the magnitude of the force of gravity, which was this, and since when you hold the piece of tape together, they are stationary in the air, so F net would equal 0 since there's no acceleration. So then that means that the magnitude of the electric force is the same as the magnitude of the force of gravity. So with this, I can set this equal to Coulomb's law, plug in the known constants and values, and then solve for Q, which is a charge, and then we get that the magnitude of the electric charge on one piece of tape is 9.333 times 10 to the negative 9 coulombs. And then with this number, we can see the number of excess electrons that was lost from the tape by dividing this number right here by the 1.6 times 10 to the negative 19th that was defined earlier, and to get 5.83 times 10 to the 10 excess electrons. And finally, to find the ratio of excess electrons to the number of atoms on a sticky surface, we took the area of the atom from the previous slide and then divided it by the number of excess electrons lost, and then we ended up getting this number right here. So now I modeled this experiment with code in GlowScript and defined the same things that we had on the previous slides, created the objects of each one, as you can see. Tape B is the red one, tape A is the blue one, and then calculated the forces. You can see the forces are equal and opposite, so then that's when F net equals 0. And did all the same calculations we did on the previous slide to get about more or less the same numbers that we had on the previous slide. And with the results from the previous slide, seeing we got very similar numbers, we can see that the computational model very accurately predicts the experiment because it produced very similar numbers to what I got during the lab. Now possible sources of error. Since we assumed since we ignored air resistance and treated the tape as a point charge and assumed the tape had the same amount of evenly distributed charge, some possible errors could have been that the tape could have had an unequal charge distribution. Charge might have changed due to the handling of the tape, and charge might not have been the same for each attempt that we did. So what if the electrons had a positive charge and the protons have a negative charge? What would change about the observations you made with your tapes and other charged objects? The observations would stay mostly the same. However, the charge of the tape would now be negative instead of positive. So for example, with the negatively charged pen, the tape would now repel from the pen. And why is it important to handle the charged tapes as little as possible? And what happens when the tapes comes into contact with your hands or other objects? It is important to handle the charged tapes as little as possible because when you touch the tape with your hands or other objects, it begins to neutralize the tape as your hands or other objects gain back electrons they have lost. And that's about it for this lab. Thank you for watching.